Good morning, friends. Today we'll discuss some 3Z interview questions. So there's a lot of queries and interest from your side. I think you're excited to have some interview questions and answers. So let's take the top most 5 interview questions and I'll answer them for you. So let's go one by one. The first question would be, explain the EC anode and RSCP and on what channel they are measured. So EC anode is energy of carrier over all the noise, which includes the thermal or the background noise plus the interference from one cell and from the other cell over the total wideband power. So that's EC anode, and RSCP is receipt signal code power, and both of them are measured in the C pitch or the pilot channel, common pilot channel. That's the full form of CPICH. The second question mostly asked is, what does channelization codes do and what are the functions of the channelization codes? So channelization codes are used for spreading and despreading of the signals. They also create the channels, making it possible to distinguish between users, connections, and different type of channels. And there are certain spreading factors associated with all the channelization codes, which is again depends on what kind of services and what is the bandwidth available or required by the services. So that is all about the channelization codes and the function. Then the third mostly asked question is, what does the scrambling codes do and what are the functions? Scrambling codes make it possible for the UE to distinguish the transmissions from different cells or node Bs. So the scrambling code is normally the identity of node B or the cell, and there are total 512 number of primary scrambling codes which are planned in the network with 64 different groups of 8 primary scrambling code each. So that's all about the scrambling codes planning and scrambling codes uses. Then the next mostly asked question is explaining the concept of cell breathing. So this is a very tricky and intelligent and one of the most important questions asked many a times. So what is the cell breathing and how it works and why it is so much required and so much popular in 3Z basically. And basically cell breathing is the interference or the noise like IO or the NO, the part of EC anode or IBNO, so the interference offset or the noise offset increase as the traffic on the network increases. Since everyone is using the same frequency, we have with no frequency use, we use the same frequency in 3Z. So therefore when IO or NO increases, the UE or the BTS needs to use more power to maintain that same EB anode or EC anode or EBNO connection. When the power required is more than maximum power allowed, then the connection cannot be made. We normally reject that connection to made because we don't have enough power for that particular request. Users at the cell edge are usually the first one who lose the services, because in the cell edge we are having more interference naturally. As the service area of cell shrinks, and the reverse happen when we don't have much traffic in the network. When the traffic is lower, again the cell radius seems to be increased. So that's all about the cell breathing. Then the next popular or the fifth most popular question is the handover and different types of handovers in UMTS or WCDMA or 3Z technology. So there are soft handovers connected to more than one cell on the same frequency in the active set. Softer handover occurs when both the cells or two cells in the active set belongs to the same node B. And intra-frequency head handover is when UE moves from one cell in one RNC to the cell in another RNC where we don't have the IUR link between each other, both of the RNCs. So that is intra-frequency head handover. Then inter-frequency head handover when UE changes from one frequency of WCDMA to another frequency, usually due to traffic layer management, or quality reasons, or like we say load-based handover or something. Then we are having inter RAT handover, which is very popular, IRAT handover. This handovers happens from UMTS to GSM, usually at the cell edge where we don't have UMTS service continuity, but also sometimes due to quality reasons. If the quality is bad, we do handover to GSM technology also. So these are the top 5 mostly asked 3G questions. I hope you learned something from this session, and thank you so much for watching this session.